Want to speak the language of chemistry? Learn to draw molecules. It's like creating blueprints for the building blocks of matter. In this guide, we'll focus on organic molecules, the molecules of life. We'll start with Lewis structures, then level up to line bond and three-dimensional representations. Drawing molecules helps us visualize their structure. This helps us understand their properties and how they react. Get ready to unleash your inner chemist. Lewis structures are a great way to start drawing molecules. They show all the atoms, bonds, and even those lonely electrons hanging out in the molecule. Think of them as the detailed blueprints of the molecule. They show how everything is connected. Let's break down the process of drawing Lewis structures step by step. Get your pencils sharpened and let's get started. First things first, we need to figure out how many valence electrons each atom has. These are the outermost electrons that participate in bonding. You can find this information on the periodic table, but here's a shortcut. For main group elements, the group number tells you the number of valence electrons. For example, carbon is in group 4, so it has 4 valence electrons. Oxygen in group 6 has 6 valence electrons. Get it? Good. Now we can move on to building the molecule's framework. Now let's arrange the atoms. The least electronegative atom usually goes in the center. Think of electronegativity as an atom's desire to hog electrons. Carbon is a popular choice for the center, especially in organic molecules. Why? Because carbon loves to bond with other atoms, including itself. Connect the atoms with single bonds, represented by lines. Think of these bonds as the glue holding our molecule together. Section 5. Distributing electrons. Completing the puzzle. Remember those valence electrons? Time to put them to work. Distribute the remaining electrons as lone pairs, trying to give each atom 8 electrons except hydrogen, which only wants 2. This is called the octet rule. Sometimes you'll need to form double or triple bonds to satisfy everyone's octet cravings. Double-check your work. Make sure the total number of electrons you used matches the total number of valence electrons we counted earlier. Section 6. Organic structures, the language of carbon. Organic chemistry is all about carbon-containing compounds. To simplify things, chemists often use line bond structures. In these structures, carbon atoms aren't always shown explicitly. Each corner or endpoint of a line represents a carbon atom. Hydrogens bonded to carbon are often omitted too. It's like a secret code, but once you learn it, it makes life so much easier. Just remember, carbon always forms 4 bonds. So if you see a carbon with only 2 bonds drawn, it means there are 2 implicit hydrogens attached to it. Section 7.3. D structures. Molecules in space. Molecules aren't flat, they exist in 3 dimensions. To represent this on paper, we use wedge dash notation. Solid wedges mean the bond is coming out of the page towards you. Dashed wedges mean the bond is going away from you, into the page. It's like giving your molecules a pop-up effect. Understanding 3D structures is crucial for understanding how molecules interact with each other. Section 8. Tips and tricks. Draw like a chemist. Here are some pro tips to up your molecule drawing game. Use graph paper or software for neatness. Always check your valency. Make sure each atom has the correct number of bonds. Don't forget to label charges and lone pairs. Simplify when possible. Use condensed or skeletal formulas for complex molecules. Remember, practice makes perfect. Section 9. Conclusion. Keep practicing. Congratulations, you've just taken your first steps into the world of molecular drawing. Remember, drawing molecules is like learning a new language. It takes time and practice. Don't be afraid to make mistakes. That's how we learn. There are tons of resources available online and in libraries to help you on your journey. So keep practicing, keep exploring, and keep those molecular masterpieces coming.